Graphing exponential functions. Exponential functions, they look one of two ways. Y equals a to the x. Either it looks that way, it gets closer and closer to the x-axis, or it goes this way and it gets closer and closer to the x-axis. If a is bigger than 1, it looks like this. If this number a is less than 1 but positive, it looks like this. It looks like one of these two graphs. And you don't even have to remember that it looks like this if a is less than 1, and it looks like this if a is between 0 and 1. That'll be obvious, because we're going to plot these with 2 points. We're going to plot it with this point and that point. And there's no way that if you have these 2 points, can you graph it like that, because you're only going to cross one of them. The only way you can graph either this or that and cross these 2 points is if you graph it like this. Likewise, if you're given this point and that point, you can't go like that and cross both points. It has to go like that. 2 points determine an exponential function. They have to be 2 intelligence points. What you always want to do, the 2 points you pick are the 2 values that make the power 0, which is when x is 0, and the x value that makes the power 1. There's only one value that makes this power 1, and that's when x is 1. Well, 2 to the 0 is 1, and 2 to the 1 is 2. With those 2 points, we can graph this. When x is 0, you go up 1, and when x is 1, you go up 2. And there's your graph. There's your graph. Problem's done. 2 points. If you were asked to graph y is equal to 2/3 to the x, when is that power 0? That happens to be when x is 0. When is this power 1? That happens to be when x is 1. 2/3 to the 0 is 1, and 2/3 to the 1 is 2/3. So when x is 0, we go up 1, and when x is 1, you only go up 2/3. And the graph goes like that, where it should have crossed 2/3. I blew it, I admit. So what I'll do is I'll put my 1 here. And there's your graph. 2 points. That's all it takes. This point and that point. And this point up here should be 1 is right there. And there's the graph. Get closer and closer to the x-axis. What if you were given the following? You're told that the graph goes like this, and it crosses at 1, and it crosses at 2, 9. And you know that y equals a to the x. So the job is to find out what a is. Now, if you think about it, this point here, 0, 1, well, no matter what a is, a to the 0 is always 1. So it's always going to contain the point 0, 1. But you want when x is 2 to get 9. So y is equal to a squared. So a is 3. So y is equal to 3 to the x. And 3 to the 0 is 1. That is when x is 0, y is 1. And when x is 2, y is 9. It's real easy to figure out if you're given 0, 1 and some other point. Okay, because 0, 1 is going to satisfy for any a value. What if you're given the following? You have this graph, you're told that's 1, and this point is -1, 1/5. The question is, what is the equation of this line? If that's 0, 1, then it's going to be in this form, because it's definitely going to satisfy that point. You just need it to satisfy, you need to find the a to satisfy the other point. When y is 1/5, x is -1. That means 1/5 is 1/a. Our hope is clear. A is 5. You can't divide 1 by 5 in this side and 1 by any number but 5 and still have equality. A is 5. So y is equal to 5 to the x. Y is equal to 5 to the x. Don't worry about that point. It's going to work for any a, because 5 to the 0, 3 to the 0, 2/3 to the 0, it's going to be 1. How about if you have this graph? Of course, it's going to cross the y-axis at 1. 1, and it also contains 2 1/16. So y is equal to a to the x. Satisfies that point. And when y is 1/16, x is 2. Well, if you square a quarter, you get a 16th. So y is 1/4 to the x. You could have written it as 1/4x. You could write it as 4 to the -x. But since we like it in this form, that's probably the best way of writing it. Now, what happens if we put a little bit of a phase shift on these graphs? Y equals 2 to the x minus 5 plus 1. The vertex is what makes that 0? Well, 5 minus 5 is 0. And what does that say? That says 1. So we're going to pretend, for graphing purposes, that the origin is right here. Okay, and like always, we're going to draw something that goes like that, or something that goes like that. Alright. Now, like always, we want the exponent to be 0. We want the exponent to be 1. Well, this is 0 when x is 5. And 2 to the 0 is 1, plus 1 more is 2. And we want the exponent to be 1. Well, that's when x is 6. 2 to the 1, this will be 2, plus 1 more will be 3. Okay, so here's 2 and 3. When x is 5, I go up to 2, and when x is 6, I go a little bit higher. And there's my graph. Okay, pretending that this is the axes, the graph doesn't look any different than it did before. We just moved the axes 5 to the right and 1 up. That is why that point right there is 5, 1. Just like we said the vertex would be, or the origin would be. What if we wanted to graph y is equal to 2/5 to the x plus 2 minus 3. So what's the vertex? What makes that 0 is x being negative 2. What that says is negative 3. Okay, so I go to that point, negative 2, negative 3. And when it comes to graphing my exponential graph, I'm going to make believe that these are the original axes, x, y. Of course, I don't label them x and y. I want to know what makes the power 0, and that's when x is negative 2, and 2/5 to the 0 is 1. 1 minus 3 is negative 2. And what makes this power 1 is when x is negative 1. 2/5 to the 1 is 2/5 minus 3. Oh, that's minus 3 plus 2/5. Minus 3 and then go up a little bit. Okay. So negative 2, negative 2, negative 1, negative 2, that's right here. Okay, that's 1 point on the graph. And when x is negative 1, I don't go up quite 1 from negative 3. Now if I make these 5, 1, 2, 3, 4, 5, I go up 2 of them. And here is my graph. Looks just like that graph. Looks just like that one. The big difference is that it's not with respect to the x and y axis. I'm not getting closer to x equals 0. But if I assume that these are the new axes, that's the y-axis, that's the x-axis, I'm supposed to get closer and closer to the x-axis and cross those 2 points. There's my graph. This one's a little different. What if you were asked to graph not 3 to the x, but negative 3 to the x? For the record, this is not negative 3 to the x. 3 to the x is always positive, and we put a negative sign in front of it. So negative 3 to the x will always be negative. Negative 3 to the x will alternate. Okay, so it's not that. Let's get that out of the way. Well, if we were to graph just 3 to the x, I let the power be 0 and 1. That means I let x be 0 and 1. 3 to the 0 is 1, and 3 to the 1 is 3. That graph will go like this. 0, 1, 1, 3. That graph would go like that. Okay? But that's 3 to the x. Now, for this x value, y says to go up that amount. For this one. X, this piece says to go up the same amount with a minus in front of it. That means it says go down that amount. For this x value, 3 to the x says go up that amount. Negative 3 to the x says go down that amount. For this x value, 3 to the x says go up that amount. Well, we go down this amount. And if you plot it, it's going to be this. This is negative 3 to the x. This is 3 to the x. It's just a mirror image across the x-axis. So that there is the graph. What if you were asked to graph y is equal to 2 to the x plus 1 plus 1? Well, the vertex is, well, what makes that 0 is x being negative 1. That's why I put the negative 1 in the x position, the first value. And that says 1. Y is 1. Okay. Now we play the games with the exponents. When is this power 0? When x is negative 1. 2 to the 0 is 1, plus another 1 is 2. When is this power 1? When x is 0. 2 to the 1 is 2, plus 1 more is 3. So, before I plot those 2 points, let's get the new origin in place. It's negative 1, 1. It's right here. We're going to pretend that this is the y-axis. And this here is the x-axis. Remember, a to the x gets closer and closer to the x-axis. When x is negative 1, I go up 2. When x is 0, I go up 3. And here's my graph. Nothing different. Except the origin is now, the axes are now the pink axes. And here's your graph. Let's try one more. Suppose you were asked to graph y is equal to negative 2 to the x minus 1 plus 2. Well, this is negative 2 to the x minus 1 minus 2. Let's graph this. And then we'll graph the negative of that. Okay. X, Y. So we're going to first graph 2 to the x minus 1 minus 2. The vertex is what makes that 0, which is 1, comma, what does that say? So I go to 1, negative 2. Now, again, we're just graphing what's below that line. So, I want the power to be 0, and I want the power to be 1. Well, the power is 0 when x is 1. And 2 to the 0 is 1, minus 2 is negative 1. Now I want the power to be 1. So, I'll let x be 2. 2 minus 1 is 2. So, 2 to the 1 is 2, minus 2 is 0. So that gives me 2 points for the graph in that box. Y equals 2 to the x minus 1, minus 2. So when x is 1, I go down negative 1. When x is 2, I don't go down anything. When x is 2, I'm at 0. And the graph goes like that. Okay, now we want the mirror image of this graph. The mirror image of this graph is, instead of getting closer and closer to negative 2, we're going to get closer and closer to 2. And instead of crossing this dotted line at negative 1, it's going to cross it at positive 1. And it's even going to cross that point right there. There's the graph. The green graph is the graph of y equals negative 2 to the x minus 1 plus 2. That's the graph of y equals negative 2 to the x minus 1 plus 2. And that completes this video on graphing exponential functions.